It is quarter 4. So, guys, no joke. This is one of those things where I will be very honest to the point of, like, it's embarrassing. I didn't know that square roots actually meant the root of a square, meaning, like, the shape, the square, for far too long. Like, I knew how to square root, right? Look for what number when multiplied by itself makes that. Let's have a helicopter. Do that on your own time with doing things. Dude, if I had to play to stop spinning, you're not going to sit there.
I remember.
Do you, though? Because literally, I can't focus when I have kids spinning around in circles. Not saying you can't. For all I know, it helps you. So the root of the square is quite literally just the side of the square. That is this big. And this big is just talking about area. That's it. You know how to square root now.
I wonder how to fix that.
Are we allowed to take notes on our iPad?
I don't care. As long, I mean, if you're off task, you pretty much will lose that privilege forever. But yeah, like if I catch you like on YouTube or whatever. So this is just a funny, like, haha, square roots. And then if I hadn't closed that tab, actually, roots will take whatever shape they need to be able to find water and everything else. So this is just so that they can find water and dirt. But then Logan asked, can I show cube root? And actually, if you Google cube roots there, if you grow a plant inside of a box, its roots and everything will fit to that box. Yeah, you can do square watermelons. Well, okay, they'd be rectangular prisms, really. They wouldn't be squares.
They'd be square. They wouldn't be square.
All right, so last week we talked about square roots or not square roots. We talked about the Pythagorean theorem. I have way too many of these, so I'm sure some of you guys need to pick those up, but there's nothing on there except for homework, so that's okay. So who can remind us what our Pythagorean theorem rule was? Alex in the back. When what? What is particular about ABC?
A and B have to be the two sides that are not the hypotenuse, and C has to be the hypotenuse.
Yeah, so this is why we care so much about squares and why we're going into square roots. Hey, Alina, you didn't see algebra tile, so I'm going to ask you to put those back in your bag, please, because all you're doing is playing. Or Elena, sorry. But yeah, you don't need algebra tiles. They weren't on the start screen. You don't need them. You're just playing. I can see where you got confused about tracing around the square. But yeah, the blue shapes templates are over here. So like it was one of those things we went over back in the fall. So you want one of these. Those are algebra tiles. Thank you. So if you want to be able to draw perfect squares, I know I can't. So that's why we have these. I don't think it'll work on your iPad, but I encourage you to try. But you probably just have a button that says insert square or whatever. So a squared plus b squared equals c squared when a and b are the legs and c has to be the hypotenuse. Who can remember what hypo meant? Give me a hand because I'm curious. Simon? Under. And yes, I got verification from Mrs. Goldring that we have not done stems list 3 yet. So you are welcome. You've now learned one of the stems from stems list 3. Hypo means under. Yes, you will be doing stems 3 through class. So Pythagoras then said, and we can actually extend this idea to any shape. If you have a regular polygon, now wait, regular versus irregular. What's a regular polygon versus an irregular? So I was just double checking what's going on. Audrey?
All of the angles are equal.
And
The sides are equal.
yes. So any regular polygon you put on the outsides of a right triangle, this will work. Where the size of the sides, size with a Z, then size with a D, the size of the sides, when you make it into that regular polygon, pentagon, hexagon, septagon, octagon, circles, yeah, anything that's a regular polygon, this will work. So, wait, if this is 16 squared, we'll go anybody. What then is this side length? You can just shout it out. That's why I said anybody. 4. And then this side length is, oh, crap.
5.
So wait. Well, we know how to figure out this one though, right? So we said 20 is 16 plus something, right? Avi told us a squared plus b squared equals c squared. This is your c squared. We'll call this a squared just for ease of application. So this is your b squared. So b squared must be 4. So this is 4, meaning the edge length is 2. Remember, because what squared? What times it 12 is 4? Crap. But c. It's not a nice number. So here c we can actually write as the root or the side length of, which is approximately equal to, what did you say, 4.4?
4, 7, 2, 1, 3, 5, 9, 5, 5.
Yeah, it gets
That's a nice
messy.
way. That's a nice way to write it. It would be irrational to write it any other
Would
way.
it be wrong if you wrote all the sides that way?
I know, right?
What do you mean that way?
Like
Like
instead
using
of
the
writing
radical
x
symbol?
side length like good square root of?
Yes, it would be. If you can simplify it, you do.
Okay.
So don't leave it under the radical if we can simplify it. So, now I had a student last year, I forget how high he went. I think he went to 100 squared. Maybe it was even more than that. But these are all examples of perfect squares. So I feel like I only half some of you because we're in some of that math that is not that challenging. And then we'll get back to more challenging stuff. So these, I hate that some of them are out of order. But any number that you square itself is a perfect square. And this is where I start to tell you guys, like, oh, you might as well like start to memorize. Like 25 times 25.
Well,
625.
What's 10 times 10? 12 times 12?
625.
13 times 13?
165.
15 times 15.
225.
So all of those are examples of perfect squares. When you can take an integer value, a whole length of something, and square it. Now, if I ask you like 33 squared, awkward. But actually, there's some fun rules involved in squares and different stuff. So if you're curious, try those out. The other way around, crap, who was it? What was her name? Jenny. The Jenny rule is, let's say I throw a square root at you. This is where I'm going to get challenging. So everyone on your paper, write down, sure, 130. Square root of 130. Now, square root of 130 is not a perfect square. So the idea that we can think about is if we have a square that has an area of 130 units squared, what we are trying to solve is its side length, which I'm going to call Z because my S's look like 5s. Now, Jenny thought up this really conveniently, well, it depends on the situation, but it's normally pretty darn accurate. So 130 is in between a couple other perfect squares. What's the perfect square beneath it?
114.
Ooh, 114.
I mean, 144. That's what I got.
Beneath it? 121. So please show this on your paper. And the square root above it, what's the perfect square? 144. So 121 is actually 11, right? And 144 is actually 12.
Yeah.
Now, this is where the Jenny rule comes into play and is actually really cool. Radical 130. All right, Avi, where am I going with this?
It's gonna be like in the middle of them.
Okay, but where am I going?
And that's gonna be like in the middle of 11 and 12.
Okay, but where do we go from there?
Then it's like, has to do with Z.
How far apart? How far apart are these? 23. So if in here, and everyone should be drawing along with me, if in here is a distance of 23, is radical 130 closer to 121 or 144? 121. So it has gone how much of that distance? 9. So we know it's more than 11.
1 divided by 20.
And then approximately 9 out of the radical distance. Now we don't write it in radical, but the distance between them is 23. Someone with a calculator, type in 9 divided by 23.
9, it's 9 divided by 23. 0.3913043478
0.
All right, now type in radical 130. I did not test this. I just literally 130. I pulled out of thin air.
11.40.
What the heck?
So it's off by 1/100th of a decimal place. We just through mental math got within 100th of the decimal place of the square root. For messy, non-perfect squares, guys, I hope you put this on your paper or you copy it down now. This is how we can deal with non-perfect. If it's a non-perfect square, you say, okay, what is it above? So that's our whole number. It's got to be above 11 and below 12. So we know it's 11 something. And then this is just an approximation method. Literally a 7th grade student thought this up like 3 years ago. Yeah. For her privacy, I will leave her last. Actually, she's probably more than that. I think she's like a senior now. But yeah, she. Yeah, no, she was a Phoenix student. I told her forever that rule will be named after her, and I carried.
I thought it was like a big mathematician.
No, like Jenny, like Worthington student Jenny. So, like, I bet there's probably a video of way back when we first like had that class, and we were like, wait, would this work? And if you test it, you get darn close. Now, I'm not saying use this, like, if you want an accurate answer. I mean, grab a calculator, get the accurate answer. But if you don't have a calculator, this is a pretty good approximation. Yeah. Now, in this, like, a lot of times, out to the second decimal place comes out right. It's out here that it gets goofed up. You could try other ones. Like, other ones, like 123 would be like, 2 out of the 23. And actually, it depends on the denominator. That's the big difference is, does the denominator divide out in a nice way or not? Yeah.
Where'd the 9 come from again?
How far we have traveled out of the whole distance between the radicals. So between the radicals is 23. We have gone 9 to get to 130, right? Because from 121 to 130. It's just an approximation method. That's fun. It works pretty well. No, you're good. Ask, because I want to review it. Because the 11, can you answer?
Because it's the bottom one, and you want to do that because in between, it's not fully on the upper one, so it'd be 11 squared. Like 11.999 is still 11, not 12.
Stop. If I was sitting near you, I would probably pick that up and throw it at you if I was 12. Yeah, right? I'm like 20 feet away and it's annoying. So in between, Henry, did that make sense? Or you want me to go one more time? So the 130 is between here, because I bet other classmates are iffy too. Find out where your non-perfect is between two perfect squares. I don't really like them being called perfect though, because no one's perfect. Alex?
Just clarifying, with like the 11 and 920, is that like 11 times 923?
Let's do another.
11 and 9.
Somebody give me a radical. Give me a number.
136.
Charlie.
136.
No, go 200s at least.
245.
201.
245. All right, radical 245. Write it down. 12 times 12, 13, 13, 15 times 15 is 225. We'd at least be close. I can't guarantee this is right, but what's 16 times 16? Yeah, okay.
It's closer to the 12.
So 15 and 16 actually. We then place 245. It's closer to the top. So we'll give that, I don't know, here. Yes, you are correct.
What's that?
It's a
a
song.
famous
Talks
one.
about having a girl's phone number. Like he finally got her phone number.
Don't change it.
So I don't know if they just thought up numbers that sounded good when they were sung, but the song that everyone knows is like 8675309. But there's no zip code or area code. There's no area code, so you would have to know the area code.
Oh,
That-
the
but
government won't
There's
allow that
always
phone
been
number.
area codes.
The government
Ever
won't
since
allow
there's
that.
been enough telephone numbers, we've had area codes.
I mean, how many
Yes, you
different-
can.
Come on, guys. We
Five.
can keep making it.
Go
off on a tangent.
Yes, but ever since there's been like, I don't know, we're not going down this road. Okay, Henry.
How many possible phone number combinations are there not counting the area code?
Oh well, I mean, if we count country code and every, oh, you mean not counting? That's an easy calculation. Just however many digits there are. But what? That is, it's not even a calculation. It's just literally 100, a million, 10 million, a million, 10 million. Yeah. Yes. What is that? 10 million?
The smallest phone number is probably
100
zero
million.
zero 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 zero.
No, they have to be at least 7 digits, and that's American.
I meant to say.
That's why I said
I meant to say 7 zeros. Did I not say enough zeros?
Probably, but we're going way too down a rabbit hole.
The numbers you got right.
There would have to just be at least enough digits for wherever you're calling out of to be able to route your number. You route coming out of the phone and then back in. All right, reviewing this. Henry, volunteering you, because not only did you bring up Jenny, but you also asked about this previously. What is the total distance from 225 to 256?
All right. Total distance would be 31.
Yes. And then to get to, hey, I'm just going to throw it out there. If I ask you to show me the Jenny method on a test, like, be ready to, because the skill of approximation is something we want to practice.
That distance is 20.
Yeah. So then, what do we know our whole number has to be? 15, because we're over 15, under 16. So this is going to be 15. Then we approximate. We get a little squiggly, little wavy, and we're approximating 20 out of 31 because it's gone 20 out of the total 31. So this is approximately 15.6, because it's about 2/3, but so the fraction 20 out of 31.
What's 2031?
Why would you be using the Jenny method if you're gonna
0.64516129.
Because you don't always have a calculator available, and I want to teach you guys how to approximate things and use your brain.
If you have a calculator available, why would you
If you have a calculator to calculate what the 20 over 31 would be, why would you?
I'm assuming you don't. I'm assuming you will mental math this to a close fraction.
50.652.
Jenny lives really close to here, actually.
652.
Let's try to approximate.
100.
So, alright, we will move on at this point, but let me answer all of those very middle school-y questions that I'm hearing. Yes. Is there a reason to doing this? Really? No. Not really. You don't have to know this method. However, you have been identified gifted in mathematics. Don't groan at me. You can go ahead and ask for that to be removed wherever you want. I don't know if that is actually true. No, I don't know if that's actually true. You could take whatever class you want. You can repeat this class if you want. So, here's my point. How you think about solving problems should be flexible. And just assuming I always have to use a calculator, that's lame. So Jenny, a few years ago, when she thought this up, and I'm sure that if I hung out in math long enough, at some point I'll find somebody's approximation method like this, but she started testing, does this work to approximate the decimal that comes behind the messy, non-perfect squares? And how cool is it that it does. It's off by only like 100. This is really, really, really close. And that's cool.
Doesn't really matter like that much in terms of what we're talking
Imagine it's
about.
always off by
So
100.
if we're just trying to talk about like how do we reason through mathematics, like reason with mathematics, this is really cool. Is it absolutely necessary? No. But do we have the time to take to talk about some cool other ways to solve things? Yes. Because we're gonna finish the textbook in time. It's okay.
The one that we got was
Hey, Bear, raising your hand doesn't mean you can talk. Just reminder. Avi, sorry.
Confused on the 15, on how you got 15, because isn't it closer to 16 though?
Doesn't matter what it's closer to, matters what it's over.
Oh, it's what it's over.
If we were just straight up rounding, it's closer to 16.
Yeah.
But we care that radical 245 is above radical 225. So since we have to come this way to get to 245, it's 15 and. Other questions on this method? Alright, let's move on. I do have a Desmos that we could do also. Would we rather do that? Get Chromebooks.
Are we allowed to work together?
Maybe, I don't know. I haven't ever done either of these. We'll talk about that here in just a second too. I have two different activities. You guys have to tell me which one's better. I've never done either of them. Yeah, if you get a chance to try both.
What are we doing?
Yeah. These are both practicing square roots, just in different ways.
Which one's the more fun?
I don't know. I've never done either of them.
I'm doing both.
At the same time.
Yes.
What? Nah, just try one. I think this is probably a skill that we're decently decent on. Whichever.
I'm doing
Gents, let's quit grunting at each other. We're not on an episode of Home Improvement.
My password. My password's 1 2 3. And I know the one who is genius.
I have no idea. What? Has to do with the lesson. Now the question is, do you believe me or not? The world may never know. Just like how many licks it takes to get to the center of a teacup. There's a lot of variables to be accounted for. Because I'll say the amount of solidation will change over time. That doesn't sound like enough.
Well, I'm also chewing too, but I'm
Well, that
in the
doesn't count.
process.
That doesn't count.
Why?
There's just how many licks. Not chews.
I wasn't. I didn't.
That
The
doesn't
last
count.
time I actually went through his legs and did that.
I know grandmother always says that though.
I know, what the fuck is
You need to find that toe.
Which one do you want? Geoboards or?
Yeah.
Oh, I remember
Well,
geoboards. Those
you're
things
wrong.
were fun
So
until the rubber bands broke and your strands
an
were
area
Oh.
of 4 square units, Captain. This is too easy for our class.
Stop it. I'm
I
like half
remember
dyslexic.
geoboards.
I don't know.
They were fun until the rubber bands broke and your strands
You
started
should
peeling
type
out.
with both
And it
hands.
started
Get in
breaking.
the habit. I think you guys might like the geoboards one.
So that's why it's taking.
I have those for real if you ever want to play with them. You might need to bring your own rubber bands though.
But I never enjoy doing those.
It's longer than one, but it's shorter than two.
Segments back between 1 and 2. You can't do that because then it'd be like there.
No, it wouldn't, because this is not one. This is more than one. Because it's
Yeah, but that's also. Oh.
Our elementary school EPP teacher
look.
had
So that's
these in
wrong.
his supply
What is
book.
that?
That's the. Okay.
So 1
there
plus
we go.
1,
Maybe still
1 plus
young.
That
1.
is.
She said okay. She said okay.
Yeah.
And 1.
I was thinking between 0 and.
Yeah, that would have worked.
Yeah. I'm like.
Is that important?
Well, that sounds helpful. This is square.
So is this what you're supposed to be doing right now here?
Oh, we have to write it somewhere. I was writing diagonal lines. Yes, because it's like, wait, why does my drum look so beautiful? My F was just F and then like blank space.
Oh, area. I thought they said side length. Nobody likes your cat noises.
Okay, please stop. What? We're supposed to do for the cat.
Yeah, I think we all know.
We know.
As soon as you open that tab and that tab is then go to Prodigy. You can't just shrug. You're beyond that age. If you go stab somebody in the grocery store, you're not just going to be able to shrug when the police officer asks you what happened. You made this choice. Help me understand it. Don't know what. Well, you chose to open the tab, so was it fun? Didn't trust me about your business. Might be like worth your time.
It is diagonal.
Because an important email is one thing. But the first thing you
If
want
it
to do
squares
is
a
play
rectangle.
Prodigy.
Wait, does that count as?
So,
Wait, what did you put this one?
yeah.
Seriously, who did that? Who did that?
I didn't know. Sorry.
I'm not going to say it out loud or else
My
people
bad.
will accuse me of
Good
putting
afternoon,
it in.
Karen Knight, please
Oh,
come to our
Mark.
vote office.
Yeah.
Karen Knight, please come to the vote office. Thank you.
Can you control yourself or do I have to treat you like crap?
No. Bears poop in the woods.
Oh, hey, what the heck?
Oh, wait.
You don't. Do you want to know if you can control it in private?
Bears poop in the woods, but they fart in the classroom.
Can you do it in one second or you want to spend the next 10 minutes just saying?
If I say it was fine, it was not fine.
Will you
Did
stay
he
on
just
task?
say that it wasn't?
It was not fine.
Show me.
What?
Froze Xander. Xander knows what to do.
Let's go.
He
Come to
thinks
couch.
very important.
Get on task.
That's why I stopped hurting. Yeah, so my mom got so angry at me.
Hey, whoever. Can we please not? You're making me concerned that we're choking.
Well, it was Bianca.
Okay, well, are we okay or no?
I don't know.
Bianca, are we breathing? Are we okay? I don't need the Heimlich. Heimlich maneuver breaks ribs. It is not a thing you want someone doing.
I'm gonna die. It's
Yes, broken ribs.
My rib broke.
You most normal. If you do it right. Same with CPR. Crack their sternum.
Yeah.
Well,
It
problem
just
is,
like
what I was
rolls
talking
over
about,
into
They might
my
puncture
middle
the
and
lung.
which side of
Yeah,
my
that's
head
not
now
it's better than being dead.
my cousin
Yes, you
ripped
are
his
correct.
elbow
It's better than
full
being
of
dead.
it.
If you have not tried the other activity and you feel like, I don't know, something might be more fun than the thing I'm doing, go ahead and try. Excuse me. If you are on the Geo boards activity, I have those physical Geo boards. The only issue is rubber bands. Most of the ones that we have are dried out and will like break after you stretch them like, I don't know, 3 times. So if you'd like to play with them, you are welcome to come ask me for that. But I do not guarantee that the rubber bands are worth anything.
So don't steal them.
Don't steal them. Remember,
The
kids.
rubber bands, I mean, you can steal them if you want. They're just gonna crack and like hit you in the eye or
The
something.
dead batteries were
That's
given
even
out
better.
free of charge.
My cousin ripped.
Mr. Hudson, when people go into the hospital, like with the punctured lung, what do they do?
They patch up your lung. They blow it back up.
What?
Yes, they do actually make sure that
They put some
you get
flips in
reinflated,
it.
but I think it's making mess.
Because my aunt,
It might wrap you.
got overseas deflate. Like,
Taste on it.
because she had an allergic reaction and
Yeah.
anaphylactic.
So they do actually have to like get it to reinflate.
Mr. Hudson.
Sir.